So we're going to finish off talking about global winds now. So I have a little video to try to help kind of put this in perspective. But do you kind of see the three segments that I was kind of showing on here the other day? Okay, so we kind of have one cell here, we have another cell here, and then we have another cell here. And I complained the other day, and I'll switch to purple, because basically you kind of have a mirror image of cells down in each hemisphere. Okay, so that's kind of how that goes. And they do look three-dimensional, so when we talk about these global winds, you kind of have to think of them lifting off. So let's just pick one. A lot of times, and actually kind of where we're going to start here in a minute, is right here at the equator. Now, even before you took this class, you'd be like, oh, equator, hot. And you'd be like, right, it is hot. So if air is hot, one of the things that air does is it rises. So actually, do you see right where the cells, both cell ones from the northern and the southern hemisphere, where they meet right there at the equator, okay, the air is going to rise. Now, we talked about layers of the atmosphere, and this is the troposphere, okay, it's got the most molecular particles, it's the densest, it's the closest to the Earth's surface. On top of the troposphere is the tropopause, so it actually has a lid. So that rising air hits the tropopause and goes both ways. So can you kind of see that? It hits the tropopause and it goes both ways. It goes this way and it goes this way. Okay. Cool. Well, I'm going to kind of break it up here, then coming on. Okay. So that hot spot, that equator, okay, actually in meteorology we call that the ITCZ. It's like three letters that stand for Intertropical Convergence Zone. And the thing that's converging there is, now I'm not going to go in upper elevations, now I'm going to go to the Earth's surface. The thing that's converging actually are southern winds and northern winds. They're converging. Okay, they converge and they go up because it's hot. Okay, that's what's happening, intertropical convergence zone. Now, one of the things we know, we talked about as the Earth goes around the sun, we have seasons. So honestly, even though the equator is hot, the real hot part actually wanders throughout the year. So in July, of course, we're having summertime. So in July, the intertropical convergence zone is kind of up a little bit. Okay, and in January, it's kind of down a little bit. So the other thing is, you notice it's not straight across 0 degrees latitude either. Okay, it's kind of a little bit wavy. So that's the intertropical convergence zone. So it does wiggle. It does move a little bit. Okay. So what we're going to see, I think we're going to get to the topic called monsoons. Everybody's heard about kind of the wet season, the rainy season, and the dry season, like monsoon seasons. The reason a particular place on the Earth can have monsoon seasons, kind of back-to-back, kind of weird sort of dramatic changes, is because this intertropical convergence zone is moving. Okay, so all right, so let's look at the Hadley cell. So a little bit ago, okay, the Hadley cells would be the ones, if you went ahead and labeled it 1, 2, and 3. Okay, the Hadley cell is the ones. Okay, so the Hadley cell kind of started, we kind of have butt Hadley cells, the northern Hadley cell and the southern Hadley cell kind of are butt to butt. So the intertropical convergence zone, it rises, it hits the tropopause, it goes about 30 degrees latitude in the north and south, and then drops back down. Okay, it descends or drops back down. So that's what this figure is showing you. So now we're kind of focusing on looking at the air part. So the way you look at this is down here, it is the ground part. This is the ground, okay, and this is the atmosphere. And so you're looking at it kind of like this, okay? So basically, now it's not always 0 latitude, but at the intertropical convergence zone, the hot spot, okay, the air rises, it hits the tropopause, and it goes both ways. And then about 30 degrees, it falls back down. About 30 degrees. Okay. Then what happens is that air, and we'll kind of focus on the northern hemisphere, that air then goes back towards the equator, okay? In the southern hemisphere, it goes back towards the equator too. Okay, so the air goes back towards the equator. Now, this also actually kind of corrects me a little bit. So that air that comes down about 30 goes towards the equator, and it splashes down, and some of it goes towards the poles. Now, the number 2 cell, okay, actually, and I think it was on the previous slide, that starts with letter F. That number 2 cell in both hemispheres is the feral cell. I just think of kind of like wild, so we are like wild child. So, because we are in the feral cell. The feral cell goes from about 30 to 60 degrees latitude in both hemispheres. That's the feral cell. Okay. So that's kind of how that goes. Hadley cell. Now, we talked about air that's rising and then it expands and cools, and if there's moisture, that rising, cooling air can give us our beautiful clouds. Well, the other thing is if you have a chunk of air that is going to come down, like it's going to come down right here, it's going to squish together. It's kind of like the opposite of your weather balloon that gets the size of a house. Take a weather balloon that's the size of a house and for whatever reason make it come back down, it's going to shrink back down in volume. If something gets smaller like that, it actually gets hot, okay? And so this descending air, about 30 degrees latitude, which is kind of between the Hadley and the feral cell, 30 degrees, that's very hot and dry. And a lot of times that is the latitude that you're going to find your deserts. All right. So, Hadley cell, this is a different figure. Again, it kind of goes back to showing you the whole Earth, and then it tries to show you kind of these slivers that kind of shows you what the atmosphere is doing over the Earth. Not bad. So, historic, let's see what this says. Okay. So, it is saying right about... We've been talking about 30 degrees, that descending air. Not only is it dry and warm, but also it creates these winds that are kind of wimpy winds. Wimpy winds for sailors are kind of a tricky thing. Arr. Okay, so the wimpy winds actually caused some sailors at times to lighten their load. And for you animal lovers in here, the way they lightened their load actually was to dump over their horses. Okay. So these light variable winds actually are called the horse latitudes because sailors had to kind of bail on some of their cargo. This is where I kind of picture if you were to go 30 degrees latitude, the horse latitudes, you know, between the Hadley and the feral cell where that air is descending, would you find like a bunch of like horse skeletons in the water? I'm just saying. I think we should check this out. All right. So now we get to one of our 3 surface winds, okay? Now, if somebody says that we have a prevailing wind, let's back up. I think I said the other day, I'm like, so if you want to know what our weather's going to be like, and actually Ben Franklin did this years ago, the first weather forecast actually just said, hey, whatever's happening over here, we know is going to move over here, okay? Now, this is quite a stretch from California to Iowa, okay, but closer, okay? And like I said, Ben Franklin did that. So actually we are under the prevailing what we call westerly winds, okay? So prevailing just means that's what it usually is. Do we get winds from the north? Yes. Do we get winds from the east? Yeah, okay? They're kind of swirly sometimes. But now, here in the Hadley cell, actually they are under the influence of a prevailing northeasterly wind for the northern hemisphere. So when I say easterly, that means it's coming from the east. Okay, make sure I get my east and west mixed up, okay? So actually down here, okay, remember this is the Hadley cell. The prevailing wind is like this. You're like, really? So it does actually alternate. They get this, we get this, and actually if you go without third cell, it goes back like this. So it kind of does alternate at the surface, okay? Now the reason it does that actually goes back to, remember we talked about the Coriolis force? The whole, like, you throw a ball up in the air, and if it can hang time for, a couple hours, the Earth's going to rotate underneath it, and it's going to appear like it deflects to the right in the northern hemisphere. That's the Coriolis force. That's what's happening here. So we said deflection is to the right. So here we go. Let's still stick with our Hadley cell. We'll get to the ferrule in a minute. But we said basically here at the intertropical convergence zone, about the equator, wind is going to go this way, okay, and wind is going to go this way, or air is going to go this way, and air is going to go this way. Now, if we go this way, deflect to the right, that was, deflect to the, oh, wait a minute. No, that's where air is rising. Oh, you guys, tricky. Air's rising there. I'm like, deflect to the right. Air's rising here. Where is it descending? About 30. Sorry, guys. Okay, so it's falling down about 30. It's creating, remember, it's kind of contracting and creating those warm, dry deserts. Okay, so it splashes and it goes either way. Now let's deflect to the right. Okay, deflect to the right. Deflect to the right. So I have to kind of stand up here, and I have to deflect to the right. Okay, good. I stand up here, I deflect to the right, and I do go like this. I convinced myself. I just have to do this at this point. Okay? So I'm up here. Again, this is where the air was descending about 30 degrees. Okay? The air was descending about 30 degrees. You deflect to the right, and you get the easterly wind. Final answer. Okay, so that's what happens under the Hadley cell. And they're called trade winds because, kind of go back to the whole sailor thing, they come in quite handy if you're trying to kind of go from one place to the other, and you know which trade wind you're picking up. Now, in the southern hemisphere, let's see if I can push this out. In the southern hemisphere, remember, it has a Hadley cell too. So the air ascends about 0 degrees at about the equator, intertropical convergence zone more specifically. It goes to about 30 degrees, it descends, and some goes this way and some goes that way. Now, the southern hemisphere deflection is to the left, and so that's why down here, this air, as it travels back towards the equator, or intertropical convergence zone, gets a deflection, and actually it's also an easterly. There you go. And they meet up at the intertropical convergence zone. Okay, so that was all Hadley cell. So we're switching gears. Now we're going to the ferrule cell. Ferrule? No, there's a song that goes like that. Okay, so the ferrule cell is where we are. So again, if you can kind of split up the hemisphere into 30, 60, and of course 90 is at the pole. So you kind of get in 3 segments. That second middle segment is the ferrule cell. All right. So basically we said that descending air here, about 30, okay, is going to be our surface wind. So now finally, let's go ahead, deflection to the right. That descending air, actually, that's what gives us our westerlies. Okay, our westerly. Sometimes they call these mid-latitude westerlies because we're kind of in the mid-latitude. Okay. All right. That works. So I said that the ferrule cell ends about 60. So about 60, actually, we're going to go ahead and take that ground air, and about 60, the air is going to rise again. Okay? And it's going to butt up against our polar cell. Okay? So that rising air, kind of between the ferrule and the polar cell, that rising air is going to hit the tropopause, and it's going to go either directions. One direction it's going to go finish up the ferrule cell, and the other direction it's going to go towards and be associated with the polar cell. All right. So speaking of the poles, here at the poles, both the North Pole and the South Pole, pretty cold, right? You didn't have to take this class to know it's pretty darn cold up there. So one of the things about cold air is cold air kind of sinks, like warm air rises, cold air sinks. So basically, that's kind of what we have going on at both of the poles. Okay, so kind of showing you that third cell. This is the sinking air because it's so darn cold, okay? And then right over here, and I don't know if I show it, is the ferrule cell, and over here is the Hadley cell. So that descending air from the top, that descending air, okay, let's go ahead and deflect to the right. So the descending air deflecting to the right, that is why up here in this top cell, you do get another easterly. So you get easterly, westerly, easterly. They kind of alternate like that. I call the polar easterlies, though. I'll buy that. Okay. So this is introducing something called the polar front. And we talked about weather fronts are when air masses meet. Okay, that's a weather front, air mass cold, air mass warm, they meet. Okay, so actually we have something called the polar front that meets between the Ferrel cell and the polar cell, the polar front. Okay, so kind of some different sort of figures, kind of some different sort of looks at it. Okay. So, jet streams, did we watch? Yeah, it seems like we watched, one of the videos we watched said something about jet streams. Yeah, maybe it was one yesterday. So jet streams, we have two jet streams, kind of in both hemispheres, two jet streams here, two jet streams here, and they're basically between the cells, okay? And they're just a ribbon of fast-moving air. Now this figure shows the ribbons of fast-moving air. Notice that in both hemispheres there's definitely a westerly wind. They're going from the west to the east. The other thing is they're not like straight, okay? They have a bit of what we call meandering here, kind of ribbon-like to them. They're showing them like all connected, like not disjointed, but if you follow like weather people who do the whole, not weather balloons, the hot air balloon scenario, okay, hot air balloons count on, if they're going on these long treks, basically catching the jet stream. And sometimes it is disjointed, so it gets a little exciting when it kind of stops and they're looking for it to start up again. Okay, so they may or may not entirely go around the Earth. So the two jet streams look like this. The one closest to the equator in both hemispheres is the subtropical jet, and the one closest to the poles in both hemispheres is the polar jet. The subtropical jet stream then, closer to the equator, is between the Hadley and the Ferrel cell, and then the polar jet is between the Ferrel and the polar cell. So I kind of like that, this figure I snagged off of the internet, where this is kind of a cross-sectional showing you kind of the tube of air. Cool. Okay, another figure. And after this figure, actually I'm going to hand you out a sheet for you to kind of fill in with some of these things. So this is a very busy slide. Let's look at it together. Let me put all the words up here so we can, those are all the words, and we'll kind of look at the figure. So what we've been talking about this morning is to take and divide the globe up into 3 segments, and there's kind of our 3 segments. And then we said, for instance, we said at 0 degrees latitude, we call that the ITCZ, just the hot spot. Intertropical Convergence Zone, the hot spot. Okay? Now, one of the things about hot spots like the equator, or more specifically the Intertropical Convergence Zone, which kind of moves a little bit throughout the year, is that warm air is going to rise. Okay, and remember that's where we started, and it hits the tropopause, and it goes both ways. Okay, and it comes back down about 30. Now, actually, kind of in that region, it is generally at the surface a general low pressure. So that's why we actually kind of call that band around the Intertropical Convergence Zone, we call that the equatorial low. Equatorial low. The word doldrums is just kind of added on there, I think, equatorial low. We said the horse latitudes can be, the winds can be kind of iffy at the horse latitudes, okay? The winds can be iffy here too. Okay, so this is, let's kind of talk through this together. This, I think I'm going to make it like homework. I don't have like a homework other than this. But this is something to go ahead and fill out as, this is like a little workshop. Fill it out as we go. So I'm kind of thinking, I don't want you to turn this in today, but you might have it done today. So, I'll let you take it home. I would like to collect it Monday and take a look at it, I think. So you take it home, you know, kind of work on it, but we're going to work on it together right now. Okay. So the sheet I just gave you, already you can fill in a few things. Let's see. Now, over here on the, let's see, I guess it would be the right, this right here, this arrow right here, actually, I think when it says pressure belts, I think what we're after here is equatorial low. What is that pressure belt? It's an equatorial low. Okay, what do you guys think? What would you put as the wind belt right here in the Hadley cell? I would too. I would put northeast trade winds right here. One of the things, I probably would doctor this up. So I would put northeast trade winds right here on this line. And I would go ahead and put Hadley cell right here, if you don't mind. Put Hadley cell. And then what's that cell going to be up here above it? Ferrell cell, yep. And then there's not much room but the polar cell. So let's stick with the sheet for a minute. What do you think? What is the wind belt right here between 30 and 60? Yeah, what's that? That's where we are. What's this wind? In the Ferrell cell. The westerlies. Yep, the westerlies. Either just westerlies or mid-latitude westerlies. Perfect. And then how about the line up here? What's this? What would you put for the wind belt? Polar easterlies. So now let's go back to this just a little bit. We said that the air goes down or descends about 30 degrees in both hemispheres. So that descending air actually creates kind of what we call a semi-permanent kind of a high. So actually that's what we're after for this second one right here. You see where it says subtropical high? Subtropical high. It's basically got two things there, subtropical high. That actually is the pressure belt, subtropical high there, where that at 30 degrees or so, the air is descending. A version of this definitely needs to make it to your test. I'm just saying. Subtropical high. Well, if you remember, we said where the Ferrell and the polar cell bump up against each other, that actually is a rising band again, okay? So that's why actually up about 60 degrees, you're going to have a pressure belt of a subpolar high. You kind of buy that? Subpolar high. Right here-ish. And there actually is one more thing that's on your sheet that's up there. I said that at both the poles it's really cold, and one thing cold air does is dive down. So actually at both of the poles we kind of have an ongoing polar high. So that would be what's up there. Did we get most of it? Yeah, and I see some of you kind of filling it out for both hemispheres, so that's awesome. That's kind of fun. Speaking of, let's go ahead and I have a video. Gosh, it's like 2 minutes. I'm going to go ahead and show you the video that kind of talks about what we've been talking about.